displaying a negative charge in an electric field. A negative charge, like Brianna, is attracted to the positively charged wall. As you will see in a moment, Brianna, the negative charge, will be attracted to the wall because opposites attract. Now see this action again in slow motion. Take note of how the negative is attracted to the positive. We now welcome you to the 11th annual Series Circuit Race.
And the charges coming out of the voltage gate, they're running the first bend in the circuit, going through the ammeter.
Oh, and they're registering 4.5 amps.
And they're approaching first resistor. This is a 4 ohm resistor, and they've cleared it with blazing speed. And they're rounding the second bend. Here comes the second resistor. This is a 6 ohm resistor, a more difficult one to clear.
Total resistance for this circuit is 10 ohms, the sum of 2 resistors because it's a series circuit.
And they're rounding the third quarter. This is a clear stretch. They're rounding the final lap. Back to the voltage cell.
Oh my gosh.
Hi, this is Ohm's law. V equals IR. Voltage equals current times resistance.
When getting the sum of resistance in series, all of the resistances are added together. This is why the 4 ohm and 6 ohm resistors create a series of 10 ohms in the race.
Using Ohm's law in series, we can find voltage, V equals IR. We can even find current. Current equals V over R. And lastly, we can find resistance. R equals V over I.
Thank you for watching the 11th annual series circuit race, brought to you by Physics Champions Sportcast.
We now welcome you to the 11th annual parallel circuit race, the second round of the 2010 circuit races. In this race, we will see the racers split equal groups at the branch, and for this reason, our racers will take 2 laps, going different routes each time.
This is the nature of a parallel circuit race, as the racers will split into equal groups at the split, allowing the 2 ammeters to register 0.5 amps with a total current of 1 amp.
We will now watch the race. And they're coming out of the voltage gate, rounding the first bend.
They're registering 1.0 amps on this first ammeter.
They are coming up to the second branch. Oh, and one goes down, the first trail, and the other the second. They're each registering 0.5 amps on the ammeter.
Each clear their resistors. This will be explained in our after show.
They're coming around the last bend into the voltage gate, and we'll run a second lap through the opposite.
As you've just witnessed, V equals IR applies to parallel circuits as well. The calculations of total current and total resistance are different than series.
Yes, as you saw, current splits in the branches of a series circuit equally, and the total current is the sum. Each ammeter in a branch registered 0.5 amps, and the total current was 1.0 amps.
When calculating resistance in a parallel circuit, the formula used is 1 over R equivalent equals 1 over R1 plus 1 over R2, etc., etc., etc. On a racetrack, the resistors set in parallel for each 4 ohms. The total, or equivalent resistance in the circuit was 2 ohms.
Thanks for tuning in for another episode of Physics Champions Sportcast.
In this video, we will demonstrate the use of a capacitor. A capacitor is used by positive charges leaving a battery and collecting at a capacitor to store a charge. Alex and Katie will be acting as the positive charge in this video, and Brianna will be acting as the capacitor. At a capacitor, the charges pile up. This is how a capacitor works.
Bum, bum, What's wrong with me?
It's got the devil in the pages. It's got the devil in the pages.
When you were running, your face was the funniest.
I'm hurt.